Hello, welcome to the fourth homework of the machine learning. In this lab, we are doing neural networks for handwriting digit recognition, multi-class, and this is our outlines, packages, relay activation, softmax function, and there's exercise 1, and neural networks, problem statement, dataset model representation, TensorFlow model implementation, and softmax placement. And to prevent errors from autograder, you're not allowed to edit or delete non-graded cell in this notebook. Please also refrain from adding any new cells. Once you have passed this assignment and you want to experiment if any non-graded code, you may follow the instruction at the bottom of this code. Okay, and this is the here our packages. I'm gonna stop here and I will check my environment before importing this. Then I will continue. Okay, hello again, and we can continue. Uh, I created new environment and import all of them. In here, the relay activation. This week a new activation for interest of the rectified linear unit, the relay units. And the example from the lecture on the right shows application of the relay. In this example, the derived awareness feature is not binary but has continuous range of values. The sigmoid is best for an off or binary station that really provides a continuous linear relationship. Additionally, it has an off range where the output is zero. The off feature makes really a nonlinear activation. Where is needed, this enables multiple units to continue to the result function without interfering. This examines more supporting optional log and softmax function. A multi-class neural network generates an output. One output is selected as the predicted answer in the output layer. A vector z is generated by a linear function which is fed into a softmax function. The softmax function converts z into a probability distribution as described below. After applying softmax, each output will be between 0 and 1, and the outputs will sum to 1. They can interpret as probabilities. The largest input to the softmax will correspond to the larger output probabilities. It's a basic statistic. Actually, I'm remembering this one from the statistic lectures of mine, where z equal v times x plus b and the number of the feature categories in the output layer. And here the exercise one. Let's create a NumPy implementation. Yep. And I'm gonna run this one too. Oh, okay. Actually, okay, I have to write my code in here. That's why it's given an error. And below the values of z inputs, not the particular has exponential in the numerator's magnitude difference in the values. Not as well the output values sum to 1. Okay. In here, we are just implying this one into the here. And I'm gonna click the hint. Oh, actually it gives me the whole code, I guess. Let me check it. And this is output A equals to my softmax Z, and softmax A and ATF, print softmax my softmax. I guess it's given the whole code for me actually. I wanna click here. What will we give? And then or vector implementation of it. Okay. And one implement uses for loop for the first build demonstrator, and then a second loop is calculate each output. So between difference of them is okay. Okay. Actually, this is empty. Initialized a to 0. It says here, and then by zeros or a vector implementation. Def my softmax as mp numpy exponential z and z sum by s. Okay, actually, it gives me the whole code, and I actually can use this one. Okay, let's write my code in here. Okay, sorry. my def softmax, and softmax is here. So I shouldn't write it again. Oh, okay, it says what I have to do. Arrays z and array input n and then features. So I have to write in this situation. And am I doing anything? There's a neural network, so that's okay. I'm gonna write the code here. And what we are doing, def my softmax convert a vector of values a probability distribution and arguments z and the array and inputs data and features returns a array and the array and softmax of z. Okay, my softmax z, I am having an n which is equal to the, okay, let me come here. I just need the length of it. How many, sorry, how many stuff in here, then a equal numpy zeros and zeros. This is n. I am having n. Okay, I write and the array is input data and features, and I have to write the other stuff as, okay, I have to write as sum in here, which is will be equal to 0, isn't it? Am I writing wrong in here? A z, yes, yes, we're going through, I guess. And for n in range n is summary, must be, I have to add all the time, and this will be numpy. Okay, let me come here, numpy explanation azk numpy x e z o e k. Okay, a z and must be k in here, then zk. Oops, did I made anything wrong in here? I guess no. Yeah, of course I made a, if I write k in here, I must be do it. Let's say j to here in range n, and j will be equal to return softmax of z. So j, we give the numpy zeros in a in here, so that's why I'm using a and g. It's equal numpy dot x z must be over, and it is j, and it is dividing to its summary. So find the permission and return a, isn't it? Yes, let me run it. Let me run this one. Okay, all passes come out. I have to import this one. Okay, it's going through. In last week, in the last week assignment, you implemented neural network to binary classification. This week you will extend that to multi-class classification. This will utilize the softmax activation. And in this exercise, you will use a neural network to recognize 10 handwriting digits 0 to 9 this multi-class classification text value and choices is selected. Automated handwriting digit recognition is widely used today, from recognition zip codes on mail envelopes to recognition amount written on the bank checks. And in the first of all, we are loading the dataset of here. We have 5,000 training examples of handwriting. Where I'm just posting this one. I just want to try to summarize this one. And weaving variables in here in the first element, x0 is in here. Actually, this is must be in somewhere. I don't want. Yes, in here. Check dimension 5,000 to 4, 5,000 to 1. And we are here, visualization, the data. And subset of training set in the cell below the code randomly select 64 randoms X and 2020 pixel grayscale image and display images together. And yeah, it's here the model representation neural network. You will use the assignment in the shower be shown in the figure below. This has two dense layers with relay activation followed by an output layer, which is near activation. Recall our inputs pixel values of digit input since the images are size 2020 that gives 400 outputs inputs parameter neural networks with 25 units in layer 1. It's given the information for us, and in here TensorFlow model implementation. Okay, input size, and it's given the explanation of how we can implement in TensorFlow with model.fit. And this is the exercise 2 for us. We might have the exercise 3. Oh, no. Okay. Okay. Below using Keras sequential model and dense layer with a relay activation to construct the 3-layer network described above. And expected output. Click for hints. I'm just wanted to click the hints. For constant strudel model, and we are here given the code in here. Okay, I guess I have some problem in my computer. It's freezing. I'm gonna stop recording, and after I fix this problem, and I could write in here, I will restart the recording. Okay, I couldn't be sure, and I just help in here actually. And if I understand right, we have using 3 cages in here, and let me run it. And in the model summary, and yeah, we have 3 dances, and these are my parameters. Yes, it looks true, and also I use it here to understand what should I write. Okay, I have another error. Test model 100 assets targeting input size. Yeah, okay. Has been never called and does not define it input. Let me see what will be output of this one. Unit test, task model 140. I couldn't be sure why I'm having this problem now. Const summary number of okay. Layer my model has never been called. Actually okay. What? Actually I must be called this one and summary in here. I cannot run this one, and it's given me error. But the reason it says the layer my model has never been called and thus has not defined input. Actually, I run this one. When I run this one, actually I use my model. So I must use this my model. But I'm gonna stop recording in here and I'm gonna try to fix this.